Assalamualaikum. Hi guys. We are going to focus about electronic configuration of ions. As I mentioned before, ions will form when atoms lose electrons or gain electrons. So, in order for ions to achieve a stable electronic configuration, it will transfer the electron. There are a few stable electronic configuration for ions. The first one is noble gas configuration. The second one, PseudoNoble gas configuration. And last one, HalfField orbital configuration. Let's focus one by one. For noble gas configuration, it will only apply for group 1, group 2, and group 13 elements, where those elements will transfer their valence electron to form cation with noble gas configuration. Usually, we are going to make the valence electronic configuration achieve octet configuration. However, there is a simple cases where the stability of an ion, which is duplet or octet. It depends on your element. Duplet only applicable for hydrogen, and the rest of the elements in group 1, group 2, and group 13 will form ions with octet configuration. For example, I have sodium atom with 11 proton number. Then, the number of electrons will be 11. The electronic configuration is this one. As you see, the highest n value is n equals to 3. So when n equals to 3, we know that in this valence orbital, we have 3s here. It has one valence electron. So in order for sodium to achieve the stability, it will lose or more favor to donate the electron. That is why you will have Na plus one electron that has been donated. Hence, the electronic configuration will become 1s2, 2s2, 2p6 for Na+. Now, you should do the final conclusion. Na+ achieve the noble gas configuration. As you see, the highest n value right now is n equals to 2, where you have 2s2, 2p6. So, in order for us to know whether this ion achieve noble gas configuration, we should have the same VEC just like NS2 and P6. Next, we go for PseudoNoble gas configuration. PseudoNoble gas configuration is for the species that shows the stability of noble gas, but their electronic configuration is not the configuration for the noble gas. It must contain a completely filled d orbital and f orbital electronic configuration. As general, for example, it should be ns2 np6 nd10 or ns2 np6 nd10 and f11. So the elements that should have this valence electronic configuration or this VEC should be the elements that contains more than 30 proton number or 30 electrons. That is why I will use one example, gallium. Gallium has 31 electrons. So you will have this electronic configuration for gallium, and the electrons will be filled until 4p. Now, if I want to determine the most stable ions for gallium, so I'm going to determine the highest n value, which will be n equals to 4. So you can see that in n equals to 4, you have the total number of electrons is 3. So 3 out of 8. That is why gallium is more favored to donate 3 electrons. Hence, it will be Ga3+, gallium ion with VEC as 3s2, 3p6, 3d10. Hence, I can conclude Ga3+ achieve PseudoNoble gas configuration because you have n equals to 3 with fully filled s, p, and d orbitals with the electrons. This is how you want to determine pseudonoble gas configuration, same as the general VEC. Next, we go for half-filled orbital configuration. Usually, this stability only applicable for d-block elements, because d-block element can also donate or receive electrons to achieve half-filled orbital, which is more stable. Hence, all the orbitals in the subshell are filled with 1 electron each. For example, I have manganese with 25 electrons, so I got the electronic configuration. The last filled electron in 3d orbital, please remember you follow the afbal for S first and 3d after. And now, I want to form the stable ion for manganese, should be manganese ion Mn2+, so I will remove 2 electrons from the highest orbital, which will be 4s orbital. So that's why there is no more 4s orbital in Mn2+. You can see that this 3d orbital contains 5 electrons. So as we know, 5 electrons for 3d orbital will be filled in each of them. 1, 2, 3, 4, and 5. That is why you got all of the orbitals in the subshell 3d are filled with 1 electron each. Hence, we can do the conclusion Mn2+ achieve half-filled orbital configuration. So settle for the stability of ions. Please complete try this 2.0 before entering the tutorial session with me. All the best. Bye.